And we are back with our second part of the section on significant figures. If you'll remember, before we talked about measuring and how important that was. And now we actually are going to dive into what is a significant figure and what makes them significant or not. Um, Basically, the definition of significant figures, which you might hear called sig figs as an abbreviation. Um, but the number of significant figures is determined by your measuring instrument and will affect your calculated values. So basically, in our two examples from before with the graduated cylinders, one, the marks were each in 1 unit. So it went 10, 11, 12, 13, 14, and so on. With the other ones, the marks signified the tenths place or right after the decimal. So it was 3.1, 3.2, 3.3, and so on up to 4. So that will determine the number of significant figures that we will use. What makes a number significant, or what makes it important, is basically just means it's not a placeholder number. So there are certain numbers that are just placeholder numbers, and there are other numbers that actually figure into the importance of the number. Um, so here are the rules and how to determine if a number is significant or not. Um, First of all, any number that is not a zero is always significant no matter what. Always. One, 2, 3, 4, 5, 6, 7, 8, 9. Those numbers always are significant. They always need to be a part of your calculation. Secondly, what we call sandwich zeros, which is a zero that is between two non zero numbers, those are always significant. So you see in the examples here 505 and 1002, those zeros are important, right? Without them, our number would be completely different, right? You take that zero out of the 505 and you have 55. And think about it this way: would you rather have $505 or $55? I know all of you are picking the 505, right? So those zeros are important, those sandwich zeros. Also, well, uh, leading zeros are never significant. They are just placeholders. So if all you have in the front of a number are zeros with no non zero number before them, they are not significant. I could write each of these numbers in scientific notation and I would not have the zero anywhere near them. Right? That first number would be 3 times 10 to the negative third. The second number would be 5 times 10 to the negative 1, right? I don't put in those zeros. They are not important. They're just placeholders for the decimal. Trailing zeros are significant if there is a decimal point. So 5.0, just like with our last graduated cylinder example, we had 3.80. That zero was important because it told us that the watermark was right on the 3.8. It wasn't a little bit above, it wasn't a little bit below, it was right straight on it. So that 5.0, that is significant. The 680, that is significant. And the two zeros after the 3 in 30.0, they are important because they tell us how accurate our number is. Um, Trailing zeros without a decimal point are placeholders. They are not significant. So 50. That zero is not significant. It's just holding a place. It doesn't mean anything. Um, I can write both of these numbers in scientific notation, and the zeros aren't part of it at all. 5 times 10 to the 1, 1.9 times 10 to the third power. So both of those numbers can be written without the zeros in scientific notation. Those numbers are not significant. If you hadn't noticed as we're going here, the purple numbers are significant, the red numbers are not.